Okay, the last one. Suppose you wish to leave an endowment which will fund a scholarship for $1,000 a year in perpetuity. If you can get a guaranteed rate of return of 5% annually, how much money should you set aside to fund this scholarship? So this is a present value problem. Normally for a present value problem, we integrate from 0 to big time T. Our income stream, e to the minus rt dt. So f of t is the income stream, r is the rate, and then t is the amount in time. So one thing we have to remember is all the units of time here have to be consistent. If f is measured in dollars per year, then the interest rate has to be per year, and the big T has to be in years. Well, the income stream we have is $1,000 per year. We're having an annual rate. So this would be the integral from 0 to t, 1,000 e to the negative 0.05 t dt. Well, for how many years is this? Well, in perpetuity. That means that this t is infinity. So this changes from present value to what we call the capital value. So really what we're looking for is the capital value, integral from 0 to infinity, of $1,000, 5%. And just like any improper integral, the way we interpret this is in terms of a limit. So we'll look at the limit as b goes to infinity of 1,000 e to the negative 0.05 t dt. So this is the limit as b goes to infinity. The 1,000 is a constant, so he goes along for the ride. I'm integrating an e to the kt, so my antiderivative is going to be e to the kt, but I have to divide by that k. I'm evaluating this from 0 to b. So limit as b goes to infinity. 1,000 divided by 0.05 is 1,000 divided by 5 over 100, which is 1,000 divided by 1/20th, which is 1,000 times 20. So this is a negative 20,000. Toss in the b. Minus what I get when I substitute in the 0. Well, there's already a negative there, so that's going to make it a positive. E to the 0 times 0.05, that's e to the 0. So this is the limit as b goes to infinity. E to the 0 is 1, so that's 20,000 minus 20,000 e to the negative 0.05b. And now we have to imagine b traipsing off to infinity. So we plug in really large numbers, a million, a billion, a trillion. If I plug in a very large positive number for b, this exponent becomes very large and negative. E to a very large negative number becomes a very small number. And so this takes this term to 0. The only thing that survives is 20,000. So how much should you invest today? $20,000. And that'll do it for Take Home Assignment 7.